Okay, so this is going to be the stem plot section of our notes. So it's how to create a stem plot. Okay, a stem and leaf plot more specifically. The short version is a stem plot. But in a stem and leaf plot, what's going to happen is we're going to have stems. So like if this was tens digits, or I mean like the one that we're getting ready to do would be tens digits. So I may have 1, 2, and 3, followed by 2, 3, 3, 3, 7, 8, 2, 1, 3, 5, 7, 7, 9, 9, 9, 30, 32, doesn't really matter. I'm overkilling this. So in this particular case, 3/0 is going to equal 30. Okay, that's what we're doing and how we're going to organize my data. So it's not going to be a dot plot. We're going to put a stem and leaf plot. And again, this allows us to see individual pieces of data. It's just a different way of drawing that picture. So again, we can see the individual pieces again. It is not useful for large data sets. Okay, so in creating the stem and leaf plot here, so we need to figure out what we're going to use for stems. These are all double-digit numbers, so it's going to be simple enough just to create stems of 10 or our tens units. Doesn't appear that I have any zeros here, so we can just go with 1, 2, 3, 4, 5 as we go all the way from 13 to 57. And we can just go through here, and it depends on what you want to do. Technically, we're just after a picture of data, so we don't necessarily have to put my stems in order. However, if we're going to use this to find a middle, they have to be in order. So it just depends on what you're wanting to do with it. If it's just a picture, fine. Out of order is fine. But if we're going to do a median or a middle, we have to figure that out. So it looks like that I have 13 as my smallest number. So there's 1, 2, 3 of them. So there's 13, 13, and 13, as well as a, what do we have here? Next number is 15 and a 19. So a 15 and a 19, that takes care of my tens digits. So my twos, scrolling through here, I got a 22. Looks like there's only one of those. We got a 23 here and a 23 there. So we can put down those 23s. And we have to make sure that since we're trying to compare length, make sure you're lining these digits up. Okay, I spaced mine way out. Didn't need to, but we have to make sure we're keeping that area principle intact. Okay, looks like we got a 24, 2 26s. And I forgot, what are we even plotting here? These data represent responses for 20 female AP Stats students to the question, how many pairs of shoes do you have? So I guess I could have rolled that data in there, but we saved it for a different time. Where am I at? 30s. Speaking of 30s, we have a 30. And then we have a 31 and a 34 and a 38. 40s, we got a 49 out there. 50s, we've got, looks like 2 50s. We've got a 51 and a 57. Okay, so that took care of my plotting of my stem and leaf. Now remember, on a stem and leaf plot, we have to include some type of scale or key, excuse me. So 4, 9 is going to represent 49 pairs of shoes. Okay. Now, the whole purpose of making a plot is to describe the plot. So that means that we're going to go back to our seesocks from last time. So again, it's just, you can, I'm going to do this a different way this time. I wrote out seesocks. Okay. So the distribution, distribution, see if I can butcher that word anymore. Are you going to see what it is? The distribution of pairs of shoes owned by AP Stats females is, so I've taken care of the context, Now we need S is shape. So this one's a little bit hard. I mean, we got this big old pillar of 50s out here, but in general, this is going to be skewed right. And sometimes it's a little hard when we, depending on where that scale, which way I need to look at that. This is going to be skewed right because my larger numbers, I have a few large numbers out there. So we're going to say is skewed right with a possible, and later on, right now it's generic because we don't have the mechanics to calculate the outlier, which is fine. It's 57. The center of the distribution is about where? So I know I have 20 female AP Stat students, so half of 20 is 10. So between my 10th and 11th is going to be the average of that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How is this working that we're landing on those numbers? So we fell between two 26s, so it's about 26. The data spreads from 13 to 57 or 44. Okay. So that was it. We conquered what this style problem might be as far as we created a stem and leaf plot and we had to describe the distribution. So again, that's where we want to end up at. Okay. There is another stem plot question on the next page, so we're going to conquer that one real fast. Splitting stems, back-to-back stems. So it looks like we have included some males on this. Okay. So that means that we're also wanting to do split stems, which is something different too. So splitting, there's two things that we're going to do here. We're going to split stems and we're going to make back-to-back stem plots. So the back-to-back stem plot means on one side of my graph, we're going to have females, and on the right side, we're going to have males. Okay? Now the only difference is my split stem, meaning I'm going to, if I look at my other sheet, I didn't get all crazy and have one of these have just a huge number. Okay, it didn't come out here and go forever. So that means that that wasn't too big a deal. However, if we look at the guys over here, there's a lot of single digits for guys. Okay, so we want to be able to split that up. In reality, it's not going to help us a whole lot. But, so that means we're going to have 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, and 5. So I have 0 space down here, but we'll live. Okay? Now, how do we split that? So we're going to assign numbers 0 through 5. We'll go in the top part of it. 6, 7, 8, 9. 6, 7, 8, 9. So I'm wrong. 0 through 4. Yeah, so, wow, I goofed that up. 0 through 4, meaning we have 0, if we think about this, 0, 1, 2, 3, 4. We have the middle 5, the lower 5 numbers. The upper 5 numbers are going to be 5, 6, 7, 8, 9, because 10 is going to go into the next row. Okay? So 0 through 4. So if we plot this out, we've got 4. It looks like I have 1, 2, 3 5s. We've got a 6 out there. We've got 3 7s. Okay. Now the thing is, I don't know if you need to watch me do this or not. So what I'm going to do is I'm going to pause the video, and when we come back, the chart should be filled out. So you can pause it as you watch it, I guess. Okay, so here it is, all completed. And again, I missed the scale, so we need to put a scale somewhere. As far as 1/3 equals 13 pairs. Okay, so again, we plotted both of those. This is a new looking female stem leaf plot. We did the double stems, which made it spread out a little bit more, and sometimes that helps our picture. Okay, But that's what we have as far as males and females and doing that. So we split the stems and we did back to back. So now we can compare. Okay, so we're going to compare distributions. Now, what we have to remember is when we compare, is the last two words of compare are ERs. That means we need to use our ER words. Okay. Now, my ER words aren't necessarily heart attack, broken leg, uh, auto accident. No, that's the ER's emergency room. Our ER words are going to be higher, lower, greater, less than, etc., like that. So it's really tough because I tell that joke every year, and I can see if you got it or not. When I'm doing this video, I can't tell if you got nothing. Anyway, here we go. So again, we're going to use our seesaws. I did a horrible job on this last one. Now I got to go back and fix it. So you don't have to. Where was it at? So if I come back and look through my answer, I'm sorry I'm doing this because it's random. I realized I didn't do it. We can use it as a checklist. Did I talk about the shape? I did talk about the shape. Did I include the outlier? We talked about the outlier 57. Did I give an approximate middle, 26 pairs? So I talked about the center. And did I give the spread? Yes, I did. So it's basically a checklist for my answers. So now that I've gone back and had to do that, again, I'm going to use it as a checklist. We're going to go with CSOX. Okay, context. The distribution of the number of pairs of shoes owned by female and male AP Stats students is, so all that took care of my context. In this case, we're going to say are because it's two variables, are both skewed right. Again, we're doing shape. This is going to be one of those that's likely. If we go back, just a little side note here, if we're talking about skewed right, this is something we can't go left of 0, but we can go way right. So that means this has had the very likelihood of being skewed to the right because of that. Okay, if we look at length of hair, length of hair is not going to get skewed left because I can't get any shorter than 0. However, I can have some really long hair. So that means that if I just looked at, so there are certain variables that will always be skewed one direction or another. Okay, and in this counting thing, that's all right. They are both skewed right. Okay. Um, there are potential outliers at 57 for females and at 38 for males. So far we haven't had to use any really ER words. That I took care of my shape, I took care of my outliers. Here's where it's going to come into play though. So the the female center at about 26 is larger than the male center at about. All right, so where's that going to be? We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We got 20 males as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, there it is. Fell right in there. That is about 10. So again, we use that ER words is larger. So we got to make sure we get that word in there. The spread of the female distribution is greater than the male distribution at 44, and 34, respectively. Okay, so we took care of that. We took some data, we made a picture of it, we described it, which is the process that we have to go through. All right, so we'll just leave that as a stem plot video and cut it off.